And you can go when you're ready. Thank you.
All right, thanks, Scott. Thanks for the introductions. I think the way I would put it is I've pretty much put my toes everywhere and poked my nose around everything AppSec all the way to security architecture. So it's a bit of a funny journey in a way, because I've got to experience different sides of things, like writing code, which is being used by people across the world in terms of software security, and consulting through Checkmarx and consulting independently by myself as well. And currently, I'm actively working on my startup, which is Inspector, and I'm also doing consulting on the side, so that I actually have money to pay the bills. So that's pretty much it. And I'll just give us a one simple slide on Inspector. So basically, we have three people at this point. So we have an advisor, me, and David Linton, who together started it. And our real objective is like, how can we make application security measurable, accessible, and more collaborative? And yeah, probably it's I don't want to jump into why and what's there, but actually running into the real topic and how even Inspector has come up is this very basic idea of we have AppSec engineers and we have AppSec SMEs across different organizations, whether it be a bank or whether it be a different software development firm or a IT company, or even a body shop, for instance, a big technology consulting company like say Deloitte or any of the big fours or Tata, Wipro, and so on. So everyone consumes software, everyone is interested in software security, but the actual pool of people who contribute this wealth of application security knowledge inside an organization is a handful. It's always a handful, right? And these people come with a plethora of information. That's typically how AppSec, people who are in AppSec end up becoming. You gained a lot of information, you shared this information. But how about we take this information and construct into a knowledge graph so that we can make decisions faster, smarter, and more accessible for people? And that was the basic idea behind the company as well. That's the basic idea behind ASVS-Graphs as well. But of course, we're only putting anything but just ASVS as part of the ASVS graph here. And I know there are various definitions that can come into defining exactly what is a knowledge graph. And to me, the most simplest description is we have some entities and we have linked these these entities through some sort of a description, and we represent those entities. So it could be, Big Four, we communicate this message, Big Four, to represent four large firms that are there across the world, across different geographies, and they do specific way of how they organize and conduct their business, which is through consulting. So Big Four is a representation there, and the linkage is through how they've come through history and how they've become actually Big Four as Big Four companies. So that by itself is probably not knowledge graph. So to slowly sit down and actually define what I did was we have descriptions about what a company does or what a particular software does or what maybe a particular system does, like a payment EFT POS system accepts payments and processes payments and says, yes, it's good, or no, we couldn't process, for instance. And from there, we can form, okay, CBA has made this EFT POS machine, or they are the distributors, they have given out this. We can see the CBA logo. So yes, they're part of this network. They give this to companies, or maybe to a small coffee shop downstairs somewhere in our neighborhood, for instance, right? So we have some relationship. Okay, I go to this small coffee shop in my neighborhood and they use CBA's EFT POS machine, for instance. So that's a very small network that we have formed. Now, from there, we get to see that, okay, CBA is using MasterCard. So that's a different level of entity and network relationship that we form. And finally, computers and humans together operate together and well. So this is what we see in our real world. And my example here is based on coffee and me purchasing coffee in my neighborhood. And this is how we are able to use some systems which are software or otherwise software plus humans combined. And we have a network of information And this, in my case, that's a coffee knowledge graph network. And people would say like, yeah, we use a database, we have a SQL database, MongoDB, doesn't matter. You're using structured queries at the end of the day. But when we're looking at knowledge graph, our intent is we want to look at data and infer facts. We don't want to look at data and receive data back or ask for data. So typically in a database, what you do is you say, hey, get me last 10 users who have changed their password in the last 30 days, right? So you get 10 users, select top 10 from users table where password has been modified, for instance. So you're querying for data and you get the answers back on what you're asking. But how about you change the equation and say, hey, here is the data, I want to infer something new. Now, this is not machine learning, this is not some sort of AI or anything of that sort, but rather it's just giving some information, looking at our information and saying, I want to infer this data. What can I see? How can I establish some sense or some sort of an entity relationship between all the contents in the data? And that's where we are actually heading to in terms of ASVS-Graph. And the one thing that I really think is true, at least personally, is we'll continue to use more and more technology. So today we have Apple Watches, we get wearable technology, we have a bunch of wearable technology already, we have home automation, we have micro ovens that can connect to the Wi-Fi, and maybe even to the internet. You could just turn on the microwave. Maybe you're about to reach home and you could turn on your microwave. So great, cool. If I'm lazy, I definitely want that as a feature. But technology will continue to evolve. Technology will continue to make us lazy, or we continue to call it as a smart Wi-Fi or smart home or smart microwave, whichever it might be. But for us to define what is knowledge, the definition there is we don't want to query, we want to have information that is driven by knowledge. So just to back me up and say that, yes, what is knowledge graph? We are saying that we are not querying for information, we are trying to infer information based on what we're seeing. So just as a summary, what we'll be doing today as well is we want to use knowledge graphs, and we are targeting ASVS and saying, what can I infer from ASVS knowledge graphs? Can I take these flat CSV files and make it more useful, make it more maybe enriched, for if I were to say that? And can I actually start to look at ASVS in a little different way? Because otherwise it's a 286 item that is a CSV file or a PDF file. People would maybe create a Jira card out of it, but is that really the outcome that we want, or do we want to push and change how people are going to consume ASVS? And to give us a little more background, and again, completely outside of security in general, let's say we have entity A and you want to influence entity E here. Your pathway to influence entity E is through influencing entity B and then entity E, and then you're able to influence entity E. Now, to convert that a little bit, right? Like you have an evil car that has a targeted advertisement on a mobile app, and this mobile app has access to photos and storage, your accounts, transactions, and they give you vacation suggestions, for instance. Now, I'm not saying Instagram here, but I'm just giving us a suggestion that, is this an entity relationship? And I believe yes, because they're able to, some evil corp is able to, through their mobile app. This could be a gaming application which has access to your entire storage on your phone. And, you end up getting vacation suggestions over emails because your email has been shared with a third party. You've not actually read the terms and conditions. You just want your kid to, maybe play the game, or you're playing the game yourself. So again, not quoting that this is Instagram, but I'm just giving out entity relationship model here, saying where and how and why I've drawn the influence from. But instead of targeting people with malicious advertisements and vacation suggestions, obviously I want to use it into maybe a better purpose, which is on ASVS. Now, for those of us who are new or who have never heard of OWASP ASVS, so the first about OWASP, or Open Web Application Security Project, is a community-driven effort. And the overarching goal is to make sure that we have better software security outcomes across the world. And it's a not-for-profit organization. So people spend their time, their personal time, their energy and their knowledge so that it is actually beneficial for each and every one of us across the world. And ASVS, or Application Security Verification Standard, is you could say is as a checklist. You could say it's a requirements table. You could call it however you want to, but at the end of the day, it's a good measuring gauge to say, hey, where am I in terms of my application security requirements, or where am I in terms of how good my application is in terms of overall application security benefits, or like how good is the deterrence for this application when it comes to withstanding and operating when subject to attacks, for instance. So deterrence for your application. And that's what we offer to businesses. We offer, as AppSec consultants, AppSec engineers, we offer assurance to the business that, even when subject to attack, your application would still continue to operate. For instance, someone is trying SQL injection, sure, we got rid of it. Someone is trying to do slow post DOS, sure, it's not a problem anymore. So that's the type of assurance activities that we conduct with the help of ASVS. It becomes easier because you have a guiding pillar or a scale to measure against, or have a more methodical approach. Now, quickly looking at NIST. NIST is a US government body. They create standards, not just for cybersecurity, but everything. So how do you measure miles? What is a mile, for instance? How much is a pound, for instance? And how do you convert a pound to a kilogram, maybe? I don't know. They do all kinds of crazy specifications, but they've had a significant of their contributions, which are directly in the cybersecurity landscape. They also have significant in the privacy and security controls landscape. So today we'll be looking at a little bit of NIST and their special publication called SP 853, because OWASP ASVS has some references to NIST. And then finally, CWEs, and this is pretty much anyone AppSec engineers dictionary in a way. So common weakness enumerations are a key pair to say, hey, CWE do something that is input validation errors. So you have a number that relates to some description, which is software security weakness description. And across the world, we have tools that different vendors produce, and there is the same consistency to describe, hey, here is SQL injection, here is input validation, here is cross-site scripting. So instead of us using our own words, language, we have a consistent way to describe the weakness. No matter where you go, like tomorrow you're working at a different company, but the CW doesn't change. So it's a good dictionary for AppSec in general to talk about weaknesses. And I think that's all the boring stuff. And the last slide is basically saying thank you. So yeah, I think it's probably better for me to jump into a demo and see where we are. So before jumping into the demo, and I barely open sourced the repository like maybe 30 minutes ago. So there is no good documentation. This is up to me. I have to make sure that there is documentation because I do care about this project. But I'll just walk us through some of the structure on how the project is today and etc. So as of today, you can ignore everything in web because there is a template ready for consuming and starting and developing the UI, but there's actually nothing. It says, I think, put a hello world, or I don't remember what I put in there, it works or something like that. But yeah, the only thing that you want to be careful about is the HTTP headers here. And I have just this one ugly item, unsafe inline, doesn't really hurt there for style SRC as well, but yeah.
Uday, we don't, your screen is frozen. We still see the demo slide. We don't see the.
One second, let me stop sharing and start sharing again. Okay, is this any better?
Yeah, thank you.
Okay, cool. So I'll just go again back from the start here. So barely open source the repository, which is inspektre/ASVS-Graph, and I have to update the information back on the OS pages as well. So basically inside the packages at this point, anyone can ignore whatever is inside the web because it's just a ready to use template at this point. The only thing that you want to be careful about when you're deploying it is with the headers. So just with this, if you're keen about that one. that's unsafe inline for the script SRC, but everything else should be fine, including I would not waste our time talking about HTTP headers today, though. So yeah, just jump into the crux of it. So the API is actually GraphQL API. This GraphQL API then talks to Neo4j databases, and that's where things actually start getting a little interesting. So for someone who wants to get started quickly, I'll jump into Visual Studio Code, and there should be, under the web, there should be some scripts, which is how do you install a community server for Neo4j, or if you're looking to install a Neo4j enterprise, here are some instructions. I think it's very minimal difference between them, but just a simple script so that you can automate and make sure that you can get rid of this line here, which talks about SSH public key. So this is me being lazy. I just do it so that I can quickly access the server once the installation is done and all the silly stuff after that. And in my case, I have a database server, which is local, and bear with me here. So Neo4j Enterprise, there is no data at this point. So I just have a default database. And to confirm that I have no data, I'll just run a quick query here, which is get me everything. And there is no data at this point. So what I'll also do here is to confirm that I have the local API actually running. And I'll jump onto Firefox here. So this is where I have the GraphQL API from localhost ready, GraphQL playground ready, basically. And if I were to open up the documentation, and I'll look at this, I'll show the schema and etc. There is no magic here. And it's all Neo4j libraries doing the magic for me. So I'm saying, hey, I want to look for information that relates to ASVS, or I want to change information that relates to ASVS, which is delete ASVS, for instance, create ASVS input item, for instance. And I've some other options, which is set graphs, set CWE graphs, and etc., which I've created. So first step for me when I'm using my Neo4j database, but through GraphQL, is I want to actually, take the perform the activity of seeding the database with ASVS. So I'll press the play button here and jump into the code and look at what are we actually doing here. So if I were to go to the API and follow through here, all I'm doing is look at this destination ASVS file and pretty much take that JSON file and dump it into the Neo4j database. And this is, again, straight away from the OS ASVS. So it's all the standard ASVS stuff with some minor changes where instead of having chapter _ ID, I've made it chapter ID. So it's a little more TypeScript and JavaScript friendly, but nothing more. So everything else is as is straight from OS ASVS. Now, once I've done this, and if I were to run the query again, I can see that I have some data. It would be no different from, say, using a SQL database, or it would be no different from using maybe any other regularly available databases, MySQL, MongoDB, doesn't matter. So it's just data being written at this point. But the only difference is because I'm using a graph database, I have nodes and they're not connected to each other. So what's the purpose, right? So if I were to look at it as a table, probably, it's going to look up like this. Or if I look at from Neo4j desktop, it's just going to present me with a bunch of nodes. So what's the point? Like, why even, what is the point of having this graph database? So I'll go back to my GraphQL API here. And this is where we start to observe a little bit of like how the community is thinking, the community meaning here the OS ASVS contributors. So I would say set CWE graph. So previously we were talking about CWEs, which is common weakness enumeration. And when I hit this play button and go back here, and if I were to say, I don't want to return everything, or maybe I should be okay. Now this is where I've used CWEs like, CW89, which is on input validation or SQL injection and things like that, right? And I start to see a pattern here that, the contributors, which are like 500 plus people who have actually made, or more than 500 people at this point, who have helped made ASVS into ASVS 4.3 or the current version. This is how they're thinking. Like, they're thinking about software weaknesses, and they're communicating about software weaknesses as ASVS with some descriptions, with some objectives and etc. described. But it's actually small clusters of information, which is fantastic because they're not disjoint items. They're actually connected items. They're probably not strongly connected, but there is still a sense of clusters or community here, just based on one entity here, or one entity relationship, which is CWEs, or common weakness enumerations. So just based on that one item, we can see that the maximum is maybe around 7 or 8 nodes talking to each other or strongly being connected to each other at this point. So it's kind of a small cluster. So if I were to flip this question and put it around, hey, someone from security or the AppSec team have given me saying I have to solve all the level 3 ASVS, which is 286 ASVS related artifacts, right? How do I prioritize? Right? Or even as an AppSec engineer or AppSec SME or a consultant, you might be asked this question, how do I prioritize? Well, it is probably an answer, right? It's probably not the best answer, but it kind of like, makes it easier for you. You'd probably look like, better off because you might be using a SaaS tool. SaaS tool says you don't have CWE X and X, or you don't have that coming out anyway. So you have a way to determine now that, if you solve this one item, you're going to close 8 items, or you're going to close 7 items. You're going to solve X number of problems or X number of application security verification because they're strongly connected. This is how they're related. Now, at this point, one might be curious, like, what is this random cluster? I'll just pick a random cluster, zoom in a bit here. And I'm just interested in knowing what is this item. So I see that this one is CWE 320, and this is about architecture, design, and threat modeling, and it has some strong connectivity, right? So, and not to bore us to death, what I'll quickly do here is I'll just copy this requirement ID, or basically the unique identifier that comes along with ASVS. So here is one item from ASVS. I'll go back to my GraphQL. And this is where GraphQL, fully starts coming into fruition. So I want to search for ASVS. Sorry, reload this one here, and I want to query or basically ask my API saying get me data instead of changing data. So mutation is for changing in case you're new to GraphQL, and query is for getting data. So I want to query ASVS, and I'll just do this saying get me a description, but I'll apply a filter where requirement ID is this 164, which relates to architecture, threat modeling, and etc. So verify that architecture treats client-side secrets, such as symmetric keys, passwords, or API tokens, as insecure and never uses them to protect or access sensitive data. Beautiful. This is a beautiful requirement from a design perspective, threat modeling perspective, right? So now, obviously, we have these relationship. If I were to go back here in the nodes and etc. So to access this relationship back, right, what I've done, and this is where the schema comes into play. So I've defined in the schema or the GraphQL schema at this point saying there is something that is outside of ASVS, but still belongs to ASVS, which is CWASVS. I just call them for now as CWASVS, which says this could be one or more items that is still ASVS. And there is some relationship which I've established in the backend when I clicked on the play button, which is they're related by CWE to each other. Or to make it a little more easier, what I'll do is I'll zoom in a bit. So one ASVS entry here is related to the other, and the relationship is related through CWE. They basically share the same CWE identifier. That's pretty much it. And what I'll do here is, because in schema I call it as CWE ASVS, and I want to say, get me the description, get me the chapter name, section name, and I'll do the similar item here. So chapter name, section name. just to see, are they different or are they similar or what is it, and etc. Right? So I get 3 items back, and one is related to cryptographic architecture. All are actually related to a specific section, which is cryptographic architecture, right? And the only difference obviously is in the description. So you have 3 different descriptions that match up with the first description, and all of these 4 ASVS entries or verification requirements, basically, they all are talking about the same application security problem or the same CWE weakness, which is CWE 320 at this point, and this relates to cryptography. So if I were to tell someone at my organization saying, hey, this is a CWE that you need to solve because it's important, and here is how I've established the importance. So if I were to go back here, and I'll zoom out here, because it's a cluster, and this is a strongly connected cluster, we need to make sure that X problem is gone faster. So instead of saying solve 100 items or solve 200 items, which is maybe not reasonable, we can help create a prioritized list, and we can make our decisions based on this inference, which is some connectivity between the graphs. Now you might be thinking, like, is this all the types of relationships that I can establish within just the ASVS? And that's where I'll do one more small query, and that is, I'll say set NIST graph. Now at this point, I'm saying, hey, you're an ASVS requirement item. You potentially have something that relates to a NIST SP 800 of 800-53 related security control. Can you share a relationship in the backend with the, a different ASVS item here? And this might take a while to finish out, but once we see that, we'll be able to look at the graph maybe in a little different way. And I'll be a little careful here. I'd say limit to 10 items to the most. And I'll have to just pray and hope this finishes out fast. And I'm pretty much at the mercy of my MacBook to work faster at this point. I mean, this is not a great environment for running a graph database on a Mac. You want to, deploy it on a proper Linux server or a Windows server, whichever is that you prefer. And once you have the NIST graph running, this would create, like, I don't know, approximately a bunch of other relationships between the nodes, which are ASVS, and then we finally have the relationship that you can observe as NIST as well. And while this was still running, and this is where I have this item in the schema. So similar to what we saw previously, where we have one ASVS requirement having related items. We have items that are related to this based on CWEs, based on NIST, and etc. So in a matter of minutes, you could have your own knowledge graph. And this is available for free today. So if you're interested, you should be able to contribute, or you could just consume it as is, I guess. But of course, spending a lot of documentation. But the idea here is, when you've watched a Netflix movie, you get a suggestion saying, hey, here is probably related movies. And we're not obviously doing machine learning to, learn, understand behavior and then suggest, but rather we are using some entities description here, and then coming to more informed decision saying, yes, this is the relationship, so this is why it is important. So CWEs, this is the community. NIST, here is the community, right? So just tying 2 different worlds or 3 different worlds and bringing all of them together is the core idea behind ASVS graph. So we'll go back here. This is still running. And I think we'll just open up for questions shortly, but what I'll also do is I'll just start running 2 more items in the background while these get executed, right? So obviously I've got a very slow machine. That's the bane of it. But well, if you were to run this on a server, obviously it's probably going to finish out much faster. And moving quickly back to the source code, and sorry for jumping too quickly, that is the case. So what you want to do is go to packages and go to API, and you want to say yarn compile. Because at this point, what happens is, well, yes, great, I have, GraphQL API, which is a bunch of TypeScript compiled or transpiled into JavaScript. I want to run it as a single executable maybe, right? And that's my requirement because I don't want to expose my database over the internet. Obviously, that's a very bad idea. So I just compile and get a binary, and the binary gets deployed along with the server. And I have a small install script that does some funny stuff. And at the very last end, it pretty much runs as a service account, same as the database. Obviously, you could run this with any other service account within your Linux machine, but just giving you an idea that, at the end of the day, in my case, I'm using a binary and running the binary to then deploy the binary, and then I have the binary exposed through Nginx. And fingers crossed here, I think this graph is complete and this is still running, and I'll just go back here. So I see that, just return 10 items, and, it's a much stronger relationship here between these 10 items, all related to architecture related tasks when it comes to application security, threat modeling, and etc. But they're much more strongly connected, right? And obviously I'll be careful here, and hopefully I don't crash my local Mac and the database. So if I were to say 50, I can see that, the connections are pretty strong. But in this case, the only meaning here, the only direct inference here is kind of a picture that paints that, AppSec and application security in general, when we have requirements provided or when we generate requirements, the SMEs, they're knowledgeable, and their information and their recommendations are coming out in a specific way because everything is, well, kind of very strongly connected. So I think it's kind of a testament to say, 500 people across the world distributed and working together on a common idea, which is to make AppSec more accessible for people, or some sort of a measuring yardstick with ASVS as a way to provide security requirements. From an application security perspective, the community thinks alike, or the community have ended up creating items which are very strongly connected. So it also goes back to the, the OS cheat sheet series and the current description that we have, which is AppSec is hard. Life is hard, AppSec is tough, so cheat. So I think this is not a cheat though, but this is just a formal way to look at ASVS and convert this into a knowledge graph. And I think that's pretty much it from a demo perspective. What I can do here quickly is I can also query for, instead of CWA ASVS, I'll just change that to NIST. And fingers crossed with that. I'll just pick an item from here. Sorry, bear with me here. I just look back at the schema, and it's called NIST ASVS. Okay, description and chapter name and section name. And hopefully this works. Yep, this works. So I see that the first one relates to business logic architecture, but the rest talk about authentication, cryptography, and data protection, privacy, and etc. So software secure development lifecycle, and etc. Right? So there are different sections. They're all connected to each other. The connecting or the guiding pillar there is NIST. So it's kind of very beautiful to see that, how people have thought about it forefront, and everything kind of adds up. And I'm looking this as an entity relationship or as a knowledge graph model at this point. And with that, I'll probably stop sharing screen and open it up for any questions, anything else, and any feedback. Of course, any comments, I'm open to comments. And of course, this is open source as a project by itself under the aegis of OWASPs. The only pending part is me putting time and actually contributing back strongly.
Cool, thank you, Uday. So any questions or comments?
Yeah, I had a question. So first of all, thanks so much for the presentation. It was really great. I'm looking at the ASVS graph page on OWASP right now, and there are like 4 bullet points there on the top which say, what can we do with ASVS graph, right? And you say practitioners can automate the verification process. Could you tell me a little bit more about what you mean by that, like automate the verification process?
Let's say you're using a SAS tool, for instance, say Checkmarx or Snickcode or Veracode or any tool that you're using, and developers have fixed a specific finding within this tool which says CWE some number. Now what you have to do is you have to come back to GraphQL in this case, or the knowledge graph, and say, hey, get me ASVS that relate to the CWE ID, and you see a bunch of ASVS items that come up, right? So you can reverse verify, and you obviously could do this with a CSV file for sure. But instead of doing it with a CSV file, you're more formally saying, hey, get me this relationship. Someone has solved this item. Does it relate to business logic? Does this relate to cryptography? Or if your actual vulnerability relates to cryptography practice, what else as a problem have you solved, or where else can you say that this problem doesn't exist anymore? So
got it.
Yeah, so just say the biggest or the strongest identifier, CWE in our case, offers a node edge relationship of 8 items or 9 items to the best. So if a developer solves one item, one finding from a tool, we can say, hey, you have solved 8 items on ASVS, and they are maybe level 1, level 2, and level 3. And I haven't even looked at the level 1, level 2, level 3 relationship here, which is from ASVS. But it's a shortcut for us to say, hey, prioritize this item in your SAS tool because they're strongly formed relationship. Or reverse, when someone solves a vulnerability, we can look back and say, this is the ASVS related item that you've solved. So potentially you've closed out the other items as well.
Excellent, thank you. I also see this as potentially being used for justifying certain fixes, prioritizing certain fixes over others, because as we know in the AppSec space, the challenge is not to actually fix things, but to find the time and organizations to fix things. And I think this might be useful there.
And I'll be very careful there. Like, it's one way to prioritize. I mean, it might not work.
Oh, absolutely. Yeah, I mean, all the reasons that we can collect for prioritization are necessary.
Yep, spot on, spot on. 1 second, I'll just put in the GitHub link, and apologies for not having documentation. This is going to change, I think, towards the end of June to July. And I'll be using a lot of React Next.js. So it's going to make it very easy for me to create pages quickly as in terms of UI and etc. And at that point, I'll also have a GraphQL server for public consumption in general. And I haven't thought of any authentication models yet. So I'll make sure to document that information. How can people log in, say AppSec person who doesn't have a budget to, do this within their organization, just use the hosted version, quickly create some items so that, you have the flex to go forward instead of waiting for something. So it's going to be a free tool, freely hosted, whatever it is. And I have to sort out how much am I going to bleed from my pocket. It shouldn't be much.
Okay. So I have another question if nobody else does.
Go for it.
Okay, so another bullet point you have there is talking about a security recommender engine. What were you thinking on those lines?
So when we were looking at previously CWE, ASVS as the relationships, and then we finally have those items coming in GraphQL API, right? Let's say you're telling someone, solve this ASVS, And similar to the Netflix model, and this is totally inspired from Netflix. When you finish watching or when you're watching a specific TV series or a movie, you get a recommendation saying, hey, by the way, you might be interested in watching this because you watched maybe I don't know, a Marvel movie, or you watched an action movie, for instance. So you get a recommendation, which again goes with like maybe the genre or maybe the actors and etc. Right? So as an AppSec consultant or SME, you would say, hey, here is an ASVS item that I think is your requirement for your project or for a specific activity. Then you also have recommendations coming out, one based on this entity relationship, CWE, or two based on the NIST relationship, or three maybe based on something a little more advanced. In this case, you might use natural language processing to say, hey, there is something that refers password here and there, so I just want to relate them all together, right? So building some sort of a similar recommendation that Netflix would do, and I think this would be more visible and usable or realizable when I have a UI to actually show here is the recommendation engine. And I'm not even actually going to do too much of hard work there. It's basically 4 or 5 steps. One, have something in the UI ready. And on the background, make sure I have the machine learning library or graph data science library from Neo4j ready on the server. And then all I have to do is load up the data and tell them this is the entity relationships and etc. And then I have to give some weightages randomly saying, hey, this is important because it's cryptography. This is not so important because it relates to, well, business logic, right? Like an AppSec, yes, we do put a lot of time in all the technical vulnerabilities, but when it comes to business logic, yeah, at least I would lose my interest there, right? But building that bridge, and in our case, what we saw with the NIST relationship is what was a business logic verification requirement from ASVS has a consequence all the way down to cryptography and secure software development lifecycle, etc. So at the end of the day, we want to make our lives easier. So from a UI, you say cryptography and you get a bunch of items that relate to cryptography. And then also, hey, by the way, I think these are related chapters or these are related NIST artifacts.
Okay.
It's not yet there, but it is quite simple to do. The only pending part is me making all of that open source.
Yep, absolutely. Yeah, I just wanted to know what you were thinking and where, what direction this may take. Yeah, definitely. Thanks.
So I think looking at the chat, I think one of the questions that you've posted here is, does it have or will it have reference to CVEs? I've done this in the past, and I have an open source project again under Inspector, which is called VulnHub. And you need a very, very beefy server. I'm talking about 64 gigabytes, multiple cores machine to have a relationship with ASVS and CWEs and CVEs. And when you do this, you can say, hey, CVE, and then you can point all the way from CVE through CWEs and through ACSVS. So sure, you have a Node.js package which is vulnerable, and can you map this back to ASVS or a requirement, right? So it's doable. It's very hard. It's very hard in the sense it's expensive to maintain. You have to constantly get the new CVEs and run the entire entity model relationship. So the faster your server, it takes a minute maybe. The slower your server, it could take like a couple of hours to actually finish the relationship. So if you do it on a Mac like me, good luck. But if you have a good server, say at least 32, 64 gigs, I think I've put up the specs on inspector/VulnHub. So, and it's not maintained so actively because I don't have such a big server at this point. But yeah, I would probably refrain from using that project at this point. But yes, we can do that.
Hi, Uday. Sajid here. Thank you for putting up this presentation. I really liked it, but I joined a bit late in your presentation. I think I've seen most of it, but I'm still sort of like grappling with the fact that what problem are we actually trying to solve for the developers here? Is it just like creating that relationship of the issues or the requirements that we are already sort of like giving them and overwhelming them with? Or what are we sort of like trying to achieve here?
Well, one of the problems that I'm trying to solve, at least for myself in this case, to be honest, is I can't tell someone, hey, here are 286 requirements because you would fit into L3 or level 3 under OSP SVS. But for these 286 items, by the way, here is how I want you to prioritize. So here is a small cluster. And just for interest, do you want me to quickly bring it up? And I'll share my screen here so that you have a better look. So let me do one small thing, which is clear the database. And I'd say remove seed to remove data. Okay, cool. Hopefully everything is gone. Perform seed. And I'm just going, and you might be able to watch this, some of this in the recording as well. So, and last item there. So go back to the database and I'll say, get me 50 items. Wait, sorry. I'm at 300 maybe. And so at this point, instead of telling software development team or software development team manager that you have to prioritize 286 items, instead of going and trying to bite that magic bullet, the approach is to take, hey, solve this cluster 1, then cluster 2, then cluster 3, then cluster 4. So one approach of many possible approaches for us is how can we prioritize which ASVS is more important? And this is a very blind way to prioritize. So there is no context here. There is no context on like the current posture within an organization, if it is a financial company or anything. So without any context and without knowing exactly how the software development teams are actually working and operating, just based on a simple artifact, which is the CWE identifier, we're able to say, hey, this looks like a strongly connected cluster. So let's solve this 1 item, 2 item, 3 items, and 4 item, etc. I mean, it might work, it might not work. I'm not sure, but to prioritize a specific item, I think it might be helpful. So similarly, we can combine this with the NIST relationship as well, and that becomes a little more complicated at that point. But you have a way to determine saying, hey, should I prioritize ASVS item 1 or ASVS item 2? So the one which has stronger relationship is where you should be inclined to, because you'd be closing out multiple ASVS requirements at that point. So it's a reverse engineered approach, which is very agnostic. And maybe, hopefully, if we add more context or weights when we have more graph learning applied, potentially we could get a lot more information.
Got it. Thank you, Uday.
And to be honest, Sajid, I do not really have the full answer. Like, how can we prioritize, right? And this is like, maybe let me try this approach, and this is where I am today. And of course, I'm looking for validation as well, because it's not that this is going to work out. This is like examining and inferring knowledge. The first idea is, how can I take ASVS as a CSV file or as JSON file, and how can I maybe potentially infer it in a different way, right? So my approach, I see that, yes, there are items that are strongly connected when I look at it in terms of NIST or as a CWE entity. And from there, I'm trying to add and share some value.
So Uday, are you also thinking in lines of like adding some meta context about the application, right? Not the specific context, but yeah, more vague context that can actually sort of like help in shaping these for the teams? Like, is there any thought process going on in there as well?
Can you maybe help me with an instance?
Yeah, for example, so we are sort of like determining the priority of the ASVS requirements through this graph visualization, graph query. So what if we sort of like add to the database a little bit of more information about the application? For instance, it's a public application, public facing application. Would that actually change anything?
Yeah. I think it can all be done, but at that point you'd have ASVS edges and nodes, and then you have a different disconnected piece of information, which would be a project that is about an application that is exposing data externally through as a REST API, maybe for instance, or as a web application, for instance. And we have to build this context. The problem is, as AppSec, we know this information, right? And we have to take our knowledge and push it into a knowledge graph, and then we can see a lot more information. But it's doable, definitely. It'll take some time. It takes some time to initially set out these entity relationships. But once you set it out, it would make a lot of sense. You can add context between nodes, edges, and have that relationship saying CWE 89 for a web application. You can say, here is an arbitrary score, and then you can have a relationship based on that score.
Cool. Yep.
Doable, it will take some time. So adding context and or basically what I call here as the entity relationships is how you want to drive and add value. So in my case, I'm just only sharing what looks like ASVS, but maybe at some point as part of the entire open source effort, what I'll try to do is maybe attempt to bake in some use cases like this, because it might actually add value for people straight out of the box instead of just using ASVS graph and looking at ASVS and
Yeah, I
you've
agree
given
there.
me you've given me a really good idea and a little hard problem to solve as well.
Yeah.
Cool. Any other last questions for Uday? Okay, thank you, Uday. Really appreciate you to come talk. Yeah, we're organizing the next talk probably in August, and it might be an in-person event, but we will also broadcast on Zoom. We will get more information up on the AppSec Australia page soon. So thank you everybody for attending, and looking forward to seeing you again. And thanks again, Uday.
Thanks all. Thank you for having me, Scott.
Thanks, Scott, and thanks, Uday.
Thanks.
Thank you. Bye.
Thanks, Uday.
Cheers. Cheers. Bye.
Bye-bye.
Cheers.